Kafka-Nated, the show where we explore the fascinating world of Apache Kafka, from architectural deep dives to the people who make it all happen. I'm Hugh, your host, and I'm excited to be back with you for our 5th episode. As always, we've got a coffee on us for our live audience. You'll find a link to claim your voucher in the chat. Quick reminder, it's currently only available in Europe and North America, but we're working hard to expand this globally for future episodes. Today, we're diving deep into one of Kafka's most significant architectural additions in recent years, tiered storage. I'm delighted to welcome Satish D, Senior Staff Engineer at Uber and a driving force behind KIP 405, which brought tiered storage to Apache Kafka. Welcome to the show, Satish.
Yeah, thanks, Hugh, for having me on the show. I'm excited to be here and to talk about Kafka's tiered storage. It's been a long journey from the initial proposal to where we are today, uh, which is released last year and it is adopted on large scale companies. So I'm looking forward to sharing some of those experiences.
Amazing. And yeah, thank you for coming on the show. We're super glad to have you here. So, first things first, before we get into that long journey for tiered storage, you've been working on distributed systems at scale for years now. What was the storage challenge that first made you think that we needed something different for Kafka?
Yeah, so as you know, storage is the key broker resource, but workloads mostly hit recent data. It is more like a streaming storage, right? Like people want to store it and mostly consume it in real time. So, which is in some scenarios about last few minutes, several minutes to a few hours in some use cases like backfills, right? But the resource cost for storage on a broker is significant. And the main important thing here is it also adds a lot of operational complexity to handle large data on the broker. So this fundamentally boils down to separation of compute and storage, right? This wasn't something new. This had been happening in the cloud world for some times. A lot of other technologies, they try to kind of build solutions to have separation of compute and storage in their respective technologies. So we also wanted to explore building a solution in that direction with their storage in Apache Kafka.
What's it like taking on such a fundamental architectural change like that? Like this move to split compute and storage for Kafka? How do you even begin to propose something that significant?
Yeah, so it was very exciting to work on such an initiative. As you said, yeah, it is a fundamental architectural change, right? So just to give you a brief background, I was exploring a similar problem before joining Uber. So Uber, some of my earlier colleagues, so they joined Uber and they were also started exploring tier storage then. So I was asked to kind of join Uber for contributing and leading the efforts in open source and also help build a solution for Uber's environment. So our goal was to build in open source with the community like any other proposal, right? So one has to create a KIP and put the proposal details and start a discussion thread. So what we did, I mean, it was very similar, but we wanted to, what we had done is we put a very high level approach and solution to kind of gauge the community's interest. So actually the community showed a lot of interest. It was overwhelming. So yeah, from there we started. It took a few iterations to get the required details to be added into the proposals. Then, like we had several back and forth within the community across different companies.
How do you navigate that relationship with the community as you bring a kit like this into open source? Um, what was the discussion like with like other maintainers and contributors and the broader Kafka community?
Yeah. So It was a great collaboration with the community. So we started with very high level details, right? And we wanted to. I mean, we did a lot of POCs and some initial benchmarks to understand the scope of the problem, right? And what are all the touch points? Uh, because it is the storage layer, so it has all touch points across different features, right? So uh, we put the proposal. Then, like there was a lot of back and forth within the community. We used to have a weekly or I mean, like Zoom calls, uh, discussed details, right? Like the implementation details, what should be the alternatives or like trade-offs and all that. So like especially from Confluent, June helped us a lot in arriving the decisions. Uh, yeah, I mean that was a short summary. Other than June's, there are so many other people, other companies, right, which contributed to this. So we initially developed this in 2.8.expands, and we shared with few other folks which they wanted to try and give feedback, right? So starting with AWS, so they actually contributed integration test framework. Actually, Ivan was also involved in actually verifying or like the interfaces that we proposed, creating these plugins, right? Whether it is sufficient for different cloud object stores and Red Hat, and there are so many other contributors in the community.
That's so cool thinking about like this big and important change that I mean, I can't think of many places at all that be using Kafka now that couldn't benefit from tiered storage, having been made up by all these kind of bits brought in by contributors across all these different organizations that are investing in open source, right? And in putting that back into the community. With regards to obviously you've got the perspective of members of the community physically kind of contributing to this kind of grand project, but for the community more broadly as kind of Kafka practitioners, were there any aspects of the design for tiered storage that changed significantly based on community feedback during those years of bringing this into open source?
Yeah, I mean, so when we introduced, right, I mean, there were no significant changes as such, but there was uh, uh, there is a lot of discussing more about edge case scenarios, right? And bringing some gaps that were there in the proposal, right, or the solution, some edge case scenarios, right? So, I mean, those discussions actually helped us a lot in kind of ironing out the design um, to make it more reliable and scalable.
Awesome. I think that makes a lot of sense of like particularly for a project like Kafka, like reliability being like super, super important, right? I think you touched on before this idea of like adding this new storage layer, particularly around like performance testing. With this being such a complex change, how do you maintain things like performance guarantees in a reliable way? What were the biggest technical challenges in implementing that? And how did everyone working on this project help to maintain the consistency between, the existing kind of hot storage on Broker and the cold storage now in object storage?
Yeah, maybe I'll give a brief overview of like what were the major problems that it actually solves, right? And then I will dive into some of the implementation details, right? Just to
That
give
would
a
be amazing.
background to the yeah to the listeners. So when we approached this problem, so we wanted to kind of address few major problems that we observed in our production environments, right? So the first one is when in a cluster in a distributed system, so failures happen very frequently, right? Like the machines go bad, and you have to replace those machines, right, with the new ones, right? So when a broker fails, you need to replace with a new node and replicate all the required data that the old node has, right? It takes several hours to kind of bring the new node and replicate all the data to the new node to take the traffic. So the duration it takes is depends upon how much storage it actually holds. So it takes, like in our environments, it was taking from 7 to 9 hours, right? And the other scenario is rebalancing the cluster, right? So whenever you try to rebalance the cluster, so it also involves moving around a lot of data across all the live nodes of the cluster, right? And it, like, it causes some churn in the cluster, right? So that is one. And the other scenario is whenever you want to kind of migrate your hardware, right? So moving from maybe like very huge like storage to a smaller storage nodes, right? To optimize the node specs, right? So, so in that case also you have to again kind of add new nodes and then move around the data. So if you see here, so lot of the complexity, operational complexity, it is mostly about moving around the data. So we have to kind of how can we reduce moving around the data, right? So one approach is to reduce the local data as much as we can and push all this to the remote storage. When we are pushing it to the remote storage, we also get the cost efficiency part, right? Like as it is a streaming storage, you don't need uh, the data, old data, more than a few hours, right? So you can keep it in storages like S3 and other object storages. So that's how we kind of started, right? And when we implemented, so we had like we had few goals, right? Like so the goals here are like we want to kind of maintain same consistency and ordering semantics like it happens in the local storage, right? So that is the one key thing. So that is where all the complexity part is there. So the other second aspect is we want to kind of do all the heavy lifting within the broker, like whatever the feature implementation, rather than pushing it to the whatever plugin that we wanted to give. So the plugin interface is very simple, where you just need to implement, given some data, store it somewhere, right, with some identifier, and again fetch the data for a given identifier, right, and delete the data with a given identifier. But yeah, the plugin will have its own complexities in connecting to the whatever remote storage and all that. But whoever is implementing, they don't need to understand any of the Kafka storage internals, right? The third aspect is we want to maintain complete backward compatibility. So there were no changes required for clients, right? So they don't need any code changes, or they don't need to even rerun or redeploy their consumer applications. So these were the main like principles that we kind of followed. So whenever we are building a feature, or like uh, whenever we are doing more enhancements, these are the principles that we kept when other people also started contributing, right? And so other aspect that you brought is the performance aspect, right? Like how can we actually have this feature without causing any side effects on other APIs, or like other requests that are being served in the same broker, right? So we have a separate, like it is all isolated, So we have separate thread pool resources, separate purgatories, right? It is all done in asynchronous way. So whenever a request comes, it actually submits to purgatory so that all the IO threads, they don't wait for talking to remote storage and getting all the required data. So these kind of principles allowed us to kind of build this solution with good trade-offs. So we also kind of built the integration test framework. So whenever, I mean, we can always write unit tests, but we want to kind of test end to end, right? So there, the community built an integration test framework where you can actually, it gives a lot of flexibility in kind of writing different set of use cases where you can kind of plug in your own code in between the flow, right? It has the remote storage has a particular life cycle. Within that life cycle, you can add your own like verifications, rules, and all that.
Amazing.
Yeah, I hope
That's such a
that
fantastic.
clarifies, yeah, your question. Yeah.
That's such a fantastic answer. It covers so much ground, but it's great. Like really interesting seeing that whole the perspective all the way through from like, okay, well we have this problem around the economics of Kafka, and how that then translates into like all of these different pieces in open source to get it working. There's so much in that I want to I want to pick your brain about now, if that's okay. One of those things being kind of around the idea of like the modernization of Kafka, I guess. So I think you mentioned earlier this idea of physical nodes failing, requiring you to create new Kafka nodes and then having to do rebalancing, which is like a very costly operation in terms of time. How much of the effort behind tiered storage do you think is contributing to this idea of moving Kafka from being like this, like in data center, like very tightly coupled with physical hardware technology, into something that's more, I guess, like more modern in the sense of being more suitable to be deployed in the cloud or like hybrid environments?
Yeah. So as I mentioned, right, like when we move to cloud, right, so uh, when people start deploying their applications or using cloud, right, so they quickly realize, as you said, the economics, right? So we want to separate compute and storage, right? Like when you club both of them, then the costs go super high. So when you kind of separate them out, then it gives a lot of freedom to kind of choose based on your workloads. You can optimize your nodes, right? Like based on like if it is very high throughput or if you need more latency, like right. So I mean, this is the I mean, tiered storage is the stepping stone in that direction for Apache Kafka. So at that time when we put this proposal, I think yeah, there were few like vendors, right, like Kafka vendors, and even the competing Kafka open source systems. They have they have built where it gives like the cost efficiency, right? It varies from like 3x to 10x based on how much data you want to keep locally. So yeah, this has always been there, like how can we move towards less and less state maintained at the broker level, but this is the maybe the stepping stone in that direction.
That makes sense. Yeah, is that the kind of part of this sort of incremental push of Kafka, kind of in the right direction, right? But with the
Yeah.
understanding that these are always part of these kind of slower kit processes of sort of tweaking and changing and improving the design over time. I think one thing we've touched on a couple of times throughout this conversation is quite how long it took tiered storage to go from being an idea to being in mainstream Kafka. I think right at the beginning of our conversation, you mentioned obviously that coming out like last year, that you've been working on this for a long time. Can you speak a little bit to why it can take such a long time for a kip like this to make it out into the world, and what it was like navigating such a lengthy process?
Yeah, so actually, when we started the KIP, and so it took good amount of time, maybe almost a year, to kind of get the KIP accepted, right? Like we used to have bi-weekly or like tri-weekly calls in the community, back and forth, because it is a fundamental change, and we want to maintain backward compatibility. Like when we started, we thought, okay, I mean, we will maybe we won't address transactions, right? We won't address a couple of other features. But when we start, I mean, that those features can come later. But this is kind of the very core, like the integral part. So community, like the critical review, that's right, like who are actually helping us to kind of build the solution. So suggested to at least um, uh, have a high level solution on how we are going to kind of uh, address those features. So eventually we kind of actually most of those were kind of addressed in the KIP and implemented as part of the KIP. That is one part. The other part is uh, once the KIP is accepted, we know that like the design is kind of accepted, and it went through very thorough and critical reviews. We started implementing the KIP internally on 2.8. Uh, we had our goals at Uber to kind of bring this feature, right? So when we kind of implemented and put it into some workloads, right? We kind of added more and more features, right? Like having like all the operational aspects, right? Having quotas, having fine grain control on how you want to kind of fine tune the resource pools related to tier storage. So then we kind of contributed back all that code, but yeah, people's availability, right? I mean, in the community to review, and then yeah, it all took its own time. But yeah, I mean, if it is
Awesome.
a minor or like medium size feature, generally in Kafka, like it doesn't take such a long time. It took because of because of the criticality as well as the availability of uh, other critical reviewers.
That makes a lot of sense. And it's interesting, like with some of the conversations we've had on the show, particularly with people like Joseph and Greg and yourself, who are like involved in all these open source Kafka projects, really getting a sense of like the human scale of some of these projects, and how many people and how much of their time it takes to make something like this happen. Now, at the end of this long process, that tiered storage is kind of out in the world. Looking at adoption today, like what are you seeing out there in production for tiered storage? And further to that, like, do you have any advice for teams that haven't already adopted tiered storage for whatever reason, who might be considering adopting it today? Like what should they know before making the switch from just on broker to tiered?
Yeah, so just to give the background, so we are running our production traffic with tiered storage, right? On the targeted clusters, which is around 80 to 90% of the total traffic. We've been running this, I think, almost 2 to 3 years. And yeah, and what we have in our production, which is mostly there in open source. So that means it is kind of battle tested, and it is being running in production, right, for some time. Earlier it was on a different version, but the similar code that we contributed back to 3.x releases. So before enabling the tiered storage, what I mean, like one should actually understand the remote storage that they are trying to plug in, right? What are the SLAs that it provides, right? Whether those SLAs are sufficient for the workloads that they're going to run, right? I mean, their producer and consumer applications, right? And whatever plugin, I mean, Aiven built a nice set of plugins for cloud, different cloud vendors. So understand the plugin support and the respective features well, so that you can kind of fine tune and get maximum benefit out of it, right? So there are two main points. Other two main points that I wanted to discuss here is one needs to understand their topic consumption patterns, because now you're going to kind of have hot and like cold or warm kind of a tiering, right? So we should know based on the consumer applications and their SLAs, how much data to be kept in the local, how much data to be kept in the remote storage, right? So it, I mean, there are several metrics that are already available, so you can kind of monitor your workloads and come up with the right local and the complete retentions. That is one. Um, you can always set some default, but any kind of few topics based on their use cases, you can always override them at topic level. And what I suggest is, I mean, each workload is different, each environment is different. So, I mean, you can get a sense on others' benchmarks, but it is always good to do your own benchmarks based on your environment, and then kind of set all these, fine tune all these resource pools, right, which are thread pools and purgatory sizes, right, and also the read and write quotas that you want to kind of control your applications. Yeah, these are the maybe the high level that I suggest to look into.
Awesome. That's super useful advice, like having a good sense of like what data you're streaming, what SLAs you have for it, and getting into the
Right.
mechanics of understanding the metrics around that and making sure that you know what plugins you're actually going to use to implement. I think, that's great advice. We had a question through from one of our live audience members, Abhishek, asking, do you support a KIP through a POC? So I think that's a question, forgive me, Abhishek, if I'm putting words in your mouth, around before a KIP is accepted maybe or merged into Apache Kafka, what can you do if you're not a contributor to help support its adoption?
Maybe can you repeat the last part? It was breaking, so I didn't.
Sure. So I think this was a question around, obviously now 405 is merged into Apache Kafka, but back a few years ago before it was accepted, if you were someone that really wanted to see tiered storage come into open source, what could you do to support it? Would that be like doing a proof of concept or helping to contribute? Like what can you do to help bring a KIP into the world?
Yeah, I think as I touched upon that earlier, so it is um, I mean, one has to do the required POCs and benchmarks, right? I mean, that will give good confidence on like the solution or the approach, right? It will also give a lot of clarity to whoever is reviewing. So, any such KIPs, if somebody wants to propose, I think they should uh, uh, they should do these two things. Also look at like what is the surface area, the whatever feature that one is trying to build, right? If the surface area is across other existing systems and features, right? So think end to end, and cover your POC with those details, right? The second part is the backward compatibility, right? So in Kafka, I mean, as you all know, like we, I mean, backward compatibility. I don't actually never saw any other open source where uh, the backward compatibility is there for last like 6 7 years old versions, right? So that is also one aspect I think the community seeks in the new KIPs. The third part, if it has any migration, right? So be very thorough on like how the existing topics are like whatever, right? So what is the migration path for them?
Amazing. That's I think a super useful insight there for. Oh, I see. Abhishek clarifying on his question. So apologies for me, Abhishek, steering that in the wrong direction, perhaps. So he says, mean to ask, how do you prove your enhancement proposal? Do you implement a POC to convince the maintainers? If yes, how do you define the scope of a POC?
Oh, okay, okay. Yeah, I mean, even for like, I mean, such a large feature, um, uh, if not in open source, right? If you're doing it in some other internal feature, so generally the approach is to kind of, as I just mentioned, right? So what is the scope of the problem, and uh, how is it uh, what are the touch points within that like within the technology, right, with other modules or subsystems. So it is always suggest, I mean, we did those POCs before kind of putting the initial proposal, but we didn't kind of solve each and every like transactions or compaction we actually put what are our non goals, right? So then get a consensus in the community, like what uh, what is it that needs to be addressed in the initial version and what can go into a follow-up kits. So we did, yeah, a few like POCs and a few benchmarks to get clarity on the solution that we were trying to explore.
That's amazing. Thanks
But
for that,
yeah, I
Satish.
mean,
I think there's some.
community feedback was, yeah, sorry. So yeah, it is slightly kind of back and forth in the initial stages. Then we kind of get to one like conclusion. Okay, this is what we want to support in the initial version itself. Then you work
Amazing.
from there. Yeah.
Amazing. I think there's some great insight there for like anyone who wants to get involved in, I guess, any engineering project at all, where you're having to kind of make the case for a big initiative, but particularly those who want to get involved in, as you have, contributing these kind of major architectural kits like tiered storage. I think that's all the time we have, but thank you so much, Satish, for coming on the show today. I've really enjoyed like hearing about your journey with tiered storage, particularly as it's something that touches so much of my work. So thank you so much for being on the show.
Yeah. Thanks for the nice discussion, Hugh. Thank you, everyone.
Thank you. And thank you to everyone who joined us live for another episode of Get Kafka-Nated. Next time, we'll be talking about another pillar of the open source streaming world, Apache Flink, with Ben Gamble, field CTO at Viverica. If you've got topics you'd like us to explore, want to be a guest on the show, or have feedback on today's episode, please reach out to me on LinkedIn. We're always looking for new voices and perspectives from the Kafka community. Thanks for listening.